All right, so I have room for 5 trials. We did 6, so let me include a trial 6, because why not? So I'm assuming 0 feet, we're at 0 all the way across. We'll just drag that and move it. All right, my friends, who was at 25?
We were.
25 feet, give me your times.
4.5 seconds.
4.5.
4.28.
28.
4.59. 4.47. 4.34. And 4.31.
4.31. Thank you, 25 footers. So what I'm doing over here is I'm calculating the averages and medians of that data. So the average would be the actual addable up and divided by 6. The median would be put them in order, smallest to big. We talk about this in class with the tests if I walk halfway across. So that's what the median would be. I'm going to include one more thing because why not? And I want to talk about it with you guys anyway. And that's standard. That's what deviation. Deviation. It's equals to div. These 6 numbers. Write that down as well. We're going to compare that as well, get some statistics analysis. All right, 50 footers, where are you guys? 50s, 50s? Okay, Bruce, hit me.
590.
590.
587.
587.
608.
608.
630.
630.
643.
643.
630.
And 630 again. Thank you, sir. All right. 75.
That was us.
Go ahead, Nick.
7.5.
75.
7.3.
73.
76.
76.
75.
75.
77.
77.
And 75.
And 75. Cool. 100 footers. Where are you guys? Oh, go ahead, Chris.
8.37.
837. Okay.
840.
840.
816.
816.
8 even.
8 even.
Blank.
Blank. That's okay. That happens.
8.25.
825. Good. So it looks like this was my fast run, at least at the end, maybe. We'll see how that continues. 125. Go ahead, Ariel.
We have 9.47,
947.
9.5,
95.
9.6,
96.
9.69,
969.
9.7,
97.
and 9.62.
962. Awesome. Thank you. And then we've got 150.
1082,
1082.
1081,
1081.
1081,
Holy. 1081.
1072,
1072.
1041.
1041. Cool. And no trial 6?
Oh,
Did I miss one?
yeah.
I missed one, or was
I
this
thought we
5?
had 1082 twice, didn't we?
Did we? I'll just put it here. It's all good.
Oh, that's right, on yours.
That's cool.
Yeah.
Because we're probably going to look at the average time, so it doesn't really matter which trial it's in as long as we have it. 175!
11.28.
1128.
11.28.
1128.
11.41.
41.
Blank.
Blank. Cool.
11.5.
11 and a half.
And 11.
And 11 even. All right. And Crystal.
It's because I came in late.
Or Micah. Whoever's down there.
I timed it, he wrote it down.
Cool. Awesome. Good, Micah.
1220.
1220.
1221.
1221.
1238.
1238.
1255.
Huh?
1255. 1265.
1265 and
1243.
thank you. All right. So what we're looking at up here, well, there's me in Sun Valley. But we're looking at here the average time, the median time, and the deviation in the times. And the reason I put the deviation up there, deviation doesn't get talked about. Well, it doesn't talk a lot about psychology classes. You know, societally deviant or something like that because we do whatever. But the deviation would be the amount of sway. Linda mentioned, she noticed when my foot got put on the pedal, things changed. A deviation, in this particular case, standard deviation, is a way of measuring that to try to see how much deviation there is. So the larger these numbers are, the more deviation there is in my data. These are all pretty much the same. This one jumps out at me a little bit just because it's roughly double what the other ones are. Is there a weird data point in there somewhere? No, not really. I mean, 5, 9 to 6, just for whatever reason, it just ends up being a little bit more deviant over that average. Any of the data points look ridiculous, like somebody timed them wrong. They look pretty damn good. Actually, compared to most classes, you guys did this pretty much perfectly. A lot of times, like, give me your stopwatch stuff. Took you 15 minutes to get down or something like that. So you guys did a pretty nice job with this. Perfect. So, with your permission, actually, let me take a vote. Should we use the average time or the median time to take a look, or should we look at both of them and see what they both look like? Yeah, let's take a look at both of them. Maybe it won't even matter. Why can I not see? Oh, there we are. All right. Now, I lost my legend. One of those is the average and one of those is the median. I don't know which one is which. So, it looks like it doesn't matter which one we use. They're essentially the same. They're essentially the exact same. So, here's what's happened historically with the data. You guys pretty much look identical to that with experimental error. So if you look at the shape of this data, could we put a line through that data? Could we? Of course we could. I can click right here, I can click layout, I can click trend line, I can click linear trend line. Based on the average times, go for it. There's the best fit line.
Yeah.
And then we did it. Let's go home.
No.
No! Why? Because,
Hitting any of those lines.
well, but remember, it doesn't have to hit them.
Yeah, I know, but it's not even like between. It's not a like best fit line. It's not.
It's not best fit in the data. Jordan, go.
Oh, no.
What's on your mind? What's on your mind?
No, I was looking at the line.
You're looking at the data. Good. So what Jordan just said, she's looking at the data. Thank you for that. We need to look at the data and say, we shouldn't. As Asani said, we can put a best fit line on, but should we?
No.
No, that data does not look linear. That data looks curvy linear or curvy. Let me get rid of this and add instead, yeah, let's do average polynomial order 2, which would be a we'll come back into this on Monday together. We use our TIs. We use our TIs on this on Monday. There. How's that look? Hell yeah, that looks a lot better. Now, I'm cheating a little bit because I knew it was going to do this. Why? Because I've done it before. No, even before I did it, knew it was going to happen. Because gravity is an acceleration. And an acceleration is a change in velocity. And velocity is in meters per second or feet per second. Let's go with feet per second because we're Americans. So velocity is feet per second. Acceleration is feet per second, which is feet per squared second. So I cheated a little bit. I knew it was going to be quadratic. Because it wasn't just me walking down the hill. It was me riding my bike, and when I say riding my bike, that's why I didn't pedal. Because if I pedaled, I could overcome that and actually force my speed to be linear downhill. But by letting just gravity pull me to the bottom, I experienced, hopefully, some force of friction, which is the tires on the pavement, but mostly the force of gravity, which we can actually see beautifully right here. A little bit off here, a little bit under here, but on average, a pretty damn good fit. Here's my question to leave you with, as before we walk out of here today. How fast do you think I was going when I passed Crystal at marker 200? Just have a guess. Have a guess ready, and we'll figure it out. We're going to calculate it on Monday based on this. I didn't have a speedometer on my bike, nor did I have a tracker program that I used.
Miles per hour, feet per second.
Whatever makes more sense to you. Miles per hour might be a more logical unit for you to use. Because we'll do feet per second up here. We'll do the conversion in class. So, yeah, miles per hour. And speaking of conversions, ooh, somebody mentioned the second project due next week. It's all about that. It's all about dimensional analysis, just so you know. FYI, wink, wink, nudge, nudge, elbow, elbow. Project, I think it's due Wednesday. I think Nick said that, right? We'll do Wednesday. That's on dimensional analysis, so make sure you get that bad boy knocked
Got
out.
it done.
Cool? You got it done? Good.
I got it done too.
You'll know how to answer the question, what size
No, that was homework.
tadpole pump do you need for your tadpole pond when your 5-year-old asks you and all you've got is an Nalgene bottle and a garden hose to answer the question with?